Lesson 7.6, solving linear systems of linear inequalities. We have been solving linear systems of linear equations, but this time we're dealing with inequalities. So let's review what an inequality is. That is a linear, it's a linear system. It's almost like an equation, except it doesn't have the equal sign. It's going to have an inequality symbol. Okay? What we learned past lessons is that if you have a less than or greater than sign, remember your line is going to be dashed. It's a dashed line. And then we're going to have to figure out, do we shade below or above the line? Well, if it's less than, you can think of less than means below. Means we're going down, so we're going to shade below. Greater than means you're getting bigger, so you're going to shade above. Okay? And then, if we have less than or equal to or greater than or equal to, when we graph, that line is solid. Okay, it's a solid line. Still the same thing. If it's less than or equal to, you're going to shade below. If it's greater than or equal to, you're going to shade above. Okay, so when graphing a system of linear inequalities, the first step you want to take is to graph each inequality. To graph, you want to get y by itself. It's like getting it in slope-intercept form. Except the only difference is you're going to have an inequality symbol in it. You still want to find slope and y-intercept. Once you've graphed each inequality, you're going to find the intersections. Okay, so let's try this. Example 1 says to graph a system of 3 linear inequalities. Alright, so let's graph each one of these. The first one, I have y is greater than 1. Remember, to graph y is greater than 1, you're going to look at your y-axis. You're going to go to positive 1 and put a point. It's greater than, so I know my line is dashed. And since it's greater than, I know I'm going to shade above. Okay. I'm going to shade above. Second inequality, I have x is less than or equal to 4. I'm going to go the x-axis to positive 4, put a point. That is going to be a solid line because it has the equal to under it. It's less than, so that means I'm going to get smaller, so I'm going to shade to the left. Shade in this area right here. I'm not going to shade down here because that did not fit where I shaded with the other line. Okay, it has to have a common shading to it. And then my last inequality. Alright, I need to get y by itself, so I'm going to divide by 3 all the way across. So I'm going to have y is less than 2x minus 2. Okay, so to graph this line, I can see my y-intercepts at -2. Put a point. And I can see I move, or my slope is up 2 over 1. Up 2 over 1. It is less than, so that line is going to be dashed. Less than means to shade below, so here I'm going to shade below. My solution can only fall in this region right here. If a point falls on this dashed part right here, it cannot be a solution because that's a dashed line. If it falls on this solid line right here, yes, it can be a solution. If the point falls on this dashed line, no. If it falls anywhere in this shaded region, then yes, it can be a solution. All right, let's try a checkpoint here. X is greater than -2, so let's graph that. I'm going to go to x to -2, put a point, and I know it's going to be dashed because it's greater than. Since it's greater than, I know it gets bigger, so I'm going to shade to the right. Next one, I have y is less than or equal to 4, so I'm going to go to the y-axis to +4, put a point. It's solid because it has the equal to under it. And I know I'm shading below. So far, I have this area right here. And then my last inequality. I'm going to subtract 3x from each side. So that leaves me with 4y is less than or equal to -3x plus 24. Divide by 4. So I have y is less than or equal to -3/4 x plus 6. So let's graph this one. The y-intercept's at +6. Be about right here. The slope is down 3/4. Down 3/4. 1, 2, 3, 4. So it's less than or equal to, so I know my line is solid. It's less than, so I know I have to shade below. It's got to share the shading that I already have, so it looks it's going to be right here in this area. Okay, moving on. So the solution to these three inequalities is going to fall right here in this shaded region. I have this dashed line that surrounds it right here. I have a solid and a solid. If a point falls right here on this solid, it can be a solution. If it falls on this solid, it can be. If it falls on this dashed, no, because it's dashed. Or if it falls anywhere right here inside this bounded shaded region, it is a solution. Okay, this time we want to write the inequalities. It already has it graphed for us. It already has it shaded. So we need to come up with the inequalities. I'm going to relabel my y and x axis. That way I don't confuse them as lines. Okay, let's do this line right here. I can see that it's solid. I can see that it's shaded below. So I know I'm going to have y is less than or equal to. Okay, let's get it in slope-intercept form. What two things do I have to know? I have to know slope and y-intercept. So looking at this line, can I see where it intersects the y-axis? Yeah, it intercepts it at 1. So I know my y-intercept is 1. Then I'm going to choose 2 points on the line and I'm going to count the slope. I can see I'm going up 1 and then over 1, which reduces to just 1. So if I plug in my slope and my y-intercept, I'm going to have y equals x plus 1. But it's an inequality, so it's really less than or equal to x plus 1. There's your first inequality. My second line, I can see that it intersects the y-axis, so I'm going to have y. It's dashed and shaded above, so we would have greater than. And it intercepts at -2. Okay, so there's both of those inequalities. And that's basically what you're doing on this whole entire lesson.